Hi there, this is Sean, and I'm going to talk about the FAIR test unit. The idea of a FAIR test is pretty central to how scientists conduct experiments and investigations. They really want to make sure the variable or what they're trying to measure is what they actually end up measuring. And the way they do this is called a FAIR test. So, for example, for this unit, kids are going to be comparing two different brands of paper towel. This kind, Bounty, and then the large rolls that the school buys for its bathrooms. And students are going to start by looking at these two paper towels with magnifying glasses and looking at their different, investigating their different properties. This one obviously is thicker. This one is much thinner. And then we introduce the idea of absorbency, which is something that a lot of paper towel brands claim that they do well. They absorb lots of spills or lots of water. And we're going to conduct a FAIR test to see which of these two paper towel brands is more absorbent. And the way we do that is we're going to do it with a few basic materials. Some measuring cups, rubber bands, and some water. Now, in order to make sure that this is a FAIR test, one of the first things we need to do is to make sure we have the same amount of paper towels. So I cut these to be identical sizes, as you can see. And that's important because if there's any more of one paper towel or the other, it's going to absorb more water, and thus the comparison isn't fair. Now you'll notice I've got the paper towels now, each brand wrapped around the measuring cups. They're the same size measuring cups, which is important for the test to be fair. So you point this out to kids, or you elicit from them, what's the same and what's different, and they shouldn't be able to think of any differences between this one and this one. That's the important idea behind a FAIR test. Later on in middle school, they get into use terminology such as variables, but this is just getting them introduced to that basic idea in a much simpler way. So an important question we're going to be asking kids as we do this is to watch for anything that may be different between how we treat one paper towel and the other, right? To look for any differences. So water, is it the same amount? Yes, I've made sure it's 150 milliliters in each one. Exactly, that's going to be important. And then we're going to pour it onto each one and see how much water these two paper towel brands are able to absorb. You'll notice it takes some time for the water to sink in, and it's dripping down into the bottoms of these containers here. So we can't pour all at once. We've got to pour it carefully. You'll also notice that I've got a tray, a cafeteria tray right here. You can also use a tub or something else to catch any water that I spill. That's really important because if one of these overflows, right, then we're not going to have an accurate measure of how much water the paper towel is absorbing unless we can capture the water that overflows and pour it back into back through the paper towel. I think if I was to do this again, I would actually use two separate trays or two separate tubs in case the water merges, to prevent the water from merging right there. But I'm going to keep pouring, and we're going to see how much. I don't know if you can see it, but we got a little bit of water that drips into the tray here, but luckily only from this one. So we know where that water came from. We can make sure it gets through to this paper towel. So now we've ensured that both paper towels have had the same amount of water pass through them. And next we're going to measure to see just how much of that water that went through them did they actually absorb. We're going to do this with a small graduated cylinder and a funnel. This is going to be great. Start with this one. Okay, I've removed the paper towel, the rubber band, and I'm just going to squeeze it into here so we can capture that water that ran off. That got absorbed, I mean. All right, so now we know that brand of paper towel, the thicker one, we'll call that brand A, absorbed about 7.5 milliliters of water. Pour that back in here. And paper towel brand B, See how much this one absorbed. Okay, I want to get all the water out of that. Oh dear. It's below the measuring line, so I'm going to estimate about 1 milliliter. I would need a graduated, even a smaller graduated cylinder to get a more accurate measure, but clearly one absorbed a lot more water than the other. In fact, it looks like 7 times more water. So thing to do is to ask the kids again, did you see any differences between how we tested the two brands of paper towel, or were all the conditions, all the things here the same? Did we treat the paper towels the same? Was it fair? And kids really latch on to that idea of fairness, which is why we use the word fair test, and can really wrap their brains around it. So there you have it. So I've written the plan for this to be a demonstration, not something that each group does on its own. The next step is that kids will then get to try and design their own fair test for a different measure of paper towel quality, which is strength. A lot of paper towel companies make claims about how strong their paper towel is, that when it's wet or even dry, it's hard to pull apart. It doesn't tear easily. So we'll give kids some materials and let them try, and some drawing paper, and try and come up with some ideas of how they can do a fair test for strength instead of absorbency. So they've seen a model of how to do it for absorbency. They'll do it on their own for strength, and they'll come together and discuss their ideas and talk about which ideas are fair and which aren't.